We will take this ruler and place it in between these books. If I take this metal block, which is very heavy, and place it on the ruler, what will happen? The ruler will bend slightly. Now let me change the position of the block and keep it vertically. Will ruler bend the same amount? Let us give it a try. This time ruler bent more. What could be the reason for this? It is the same block after all. Force applied is the weight of the block. We just change the way block is placed. Only things which has changed is the area in contact with the ruler. Same force is applied on less area. If we measure the ratio of force applied and area, it is more when block was placed vertically. This ratio is called nothing but pressure. I have two nails, one with pointed end and one with blunt end. Which one I should hammer in the wooden block? If I use this blunt nail and try to hammer it, it won't go very far. Hammer is applying the same force, but iron nail is going nowhere. If I use the nail with pointed end instead, the same force of hammer gets the nail into the wall. That means sometimes knowing the amount of force is not enough. You have to know how the force is distributed on the surface of impact. For the pointed nail, force applied was concentrated on a very small area. For the blunt nail, the force was distributed on a large area. This concept can be precisely defined by a term known as pressure. It is the amount of force exerted per area. Pressure means how much one object is pushing on another object. It is usually more convenient to use pressure rather than force to describe the influence on other objects. Place this pin between your thumb and index finger. Now gently squeeze the pin and note the sensation. Which end of the pin causes pain? Pointed one or blunt one? If I poke you with this finger, it might irritate you. It won't have any lasting effect either. What will happen if I apply the same force, but now instead of finger, use needle? The same force is good enough to get the needle into your body. Any idea which concept we are discussing? It's pressure. Pressure is defined as force per unit area. The SI unit of pressure is Pascal, which is Newton per meter squared. How much is 1 Pascal? If dimension of the paper is 1 meter by 1 meter and it weighs 100 gram, we can say that it is applying a pressure of 1 Pascal on the table. There are many other units other than Pascal which are used commonly. Atmospheric pressure is measured in millibars. Tire pressure is mentioned in PSI, pounds per square inch. Blood pressure still refers to millimeters of mercury. Pressure is defined for solids, liquids and gases, but is particularly important for gases and liquids. Here is a small pin pointing upward. If I place balloon on it and press it gently, what will happen? It will burst. Now instead of one pin, let me place a rubber with 100 pins closely placed together. What will happen if I place the same balloon over these pins and press gently? Will it burst? No, it will not. I can even put 1 liter bottle on it. Why balloon did not burst? This has to do with pressure. Though we applied identical force, pressure was much greater when single pin is used. This was not the case when collection of pins were used. Force applied got distributed over a large area. Hence less pressure was applied to individual place. Summary. We learned about a new concept, pressure. Pressure means how much one object is pushing on another object. It is usually more convenient to use pressure rather than force to describe the influence on other objects.